Okay, 5 I found to be a difficult problem, by the way. Cosecant cubed of x, secant of x dx. The first thing I'd probably do is just get in terms of familiar functions, and for me, sines and cosines are the most familiar. Let's put this one down. That's going to be sine cubed, cosine. And that's going to be 1, and this will be dx over here. All right? The next thing I want to do is, kind of look at the number 1 and use a Pythagorean identity for that. And you get sine squared plus cosine squared dx, and at the bottom you get sine cubed x plus cosine x. The next thing I want to do is I want to split into two integrals. And the two integrals are going to be sine squared, and you're going to get sine cubed x plus cosine x dx plus cosine squared x, and then you get sine cubed x plus cosine x dx. All right, let's keep going. And I think I can do some things with this. And I'm going to think about it for a second. And let's see, sine squared. Oh, you know what? I just made a mistake in my copy, too. I just noticed it. That's a multiplication. Sorry about that. I had additions on my mind, and that would have made it much more difficult for me. But let's just simplify a little bit. All right? What are you going to get over here? Let's take a look. You're going to get 1 sine x cosine x dx plus, let's see if we can do this one now. You're going to get cosine x, and then you're going to get sine cubed. Okay, I'm still looking at it. And by the way, the second interval certainly has gotten easier for me. But I want to do that first one. And I'm looking at this thing, and I'm wondering what to do again. And I might be in a loop, by the way, but I'll try it again. But that second interval looks doable to me. And let's write this over here. I'm going to put down sine squared plus cosine squared over sine x cosine x dx. Again, we'll do this one later, but I'll write it down for you now. All right, this is a long problem, isn't it? And I'm going to split into two problems again. The first integration, by the way, it's going to be sine squared over sine x cosine x dx plus cosine squared sine x cosine x dx plus, I got this third integral to worry about, don't I? All right, let's keep going. And what do you get here? Looks like you get sine x. By the way, these cancellations are conditional. I'm not worried about the conditions at this point. Put the next one down. That's going to be cosine x over sine x. Things are getting a little bit simpler for me. Plus cosine x over sine cubed x dx. All right. And I got to go one step at a time over here. And I'm looking at this thing over here, and I got 3 integrations to do now, and I think they're all doable. I'm going to do one at a time, but I'm going to make some erasures. Some people do this in their head, by the way. I'm going to say u is equal to cosine of x. That means du would be minus sine x dx. So what do you get over here? Again, I'm going to erase this because it's really kind of side work at this point. This can be minus 1 du over u, and that would integrate to minus the natural log of u, and the u is cosine x. I'm going to bring the minus 1 up, and what would that give me? That would give me the natural log of the absolute value of the secant of x. So let me get my eraser out, because I'm kind of done with this one. That wasn't so bad. I'm going to do the next one now. The next one, very similar. I can say u equals sine x. I'm going to say du is cosine x. And again, a lot of people do this in their head. I really don't like doing things because I make mistakes when I do that. That's 1 du over u. So it's going to give you the natural log of u. And what do you get there? It's going to be plus the natural log. Well, what's u? U is sine. That's not so bad. I'll get my eraser out. Erase this business over here. And I'm going to go to that third integration, see what happens over there. So I'm going to say u is equal to sine x, and the du would be cosine x dx. So what do you get there? And again, people do this in their head. I just don't like doing things in my head. You get u cubed on bottom, and you get a du there. What's that going to be? Well, let's take a look. That would be u to the minus 3 du. That would be u to the minus 2 over minus 2. So I think I can do that. And what's it going to be? Minus, well, you're going to get 1 over 2 u squared. Well, what's u? It's sine, so it's sine squared. I get my eraser out and erase things that I don't need anymore. Again, scratch work on the side if you want to leave it there. I can put a box in this. And certainly if you want to simplify it, you can. And you know, maybe I should simplify it. But it's a good answer to me. So let me see if I can simplify this a little tiny bit. So natural log, that's 1 over cosine x, plus the natural log, that's sine x. I can pull those two together. There's going to be 1. You know, I'm going to write it as a half. And then the sign I'm going to write down as cosecant squared plus c. The two logs can be wrote together. That's natural log. Well, it's a sum, so it'll be a product. That's sine over cosine, which is tangent. Minus cosecant squared x over 2 plus c. I'll get a common denominator now. That'll be a 2. And what do you get there? 2 natural log, absolute value of tangent, minus the cosecant squared x plus c. I'm going to say it's also another good answer. I'm going to get my red pen out and take a look at it. It's a tough problem, by the way. So let's see if we got the answer. I'm seeing this. Oops, sorry about that. I'm seeing 2 natural log of tan x minus the cosecant squared over 2 plus c. I also want to point out that's a fine answer too. Whatever you write down, as far as I'm concerned, is fine. But again, depending who your teachers are, they may disagree with that. They may want what they consider to be a simpler form of it. We're good. Thank you.